Your body is, well, it's an absolutely incredible machine. But have you ever really stopped to think about the basic engineering that lets you move at all? Today, we're going to dive into the body's brilliant solution to a really complex puzzle, the joints. These are what turn a rigid skeleton into a dynamic, moving powerhouse.
I mean, really think about that for a second. Your bones, they give you structure for sure, but by themselves, they're just a stiff framework. If you were only made of bone, you'd basically be a statue. So, what's the secret? What's the magic trick that unlocks all the motion we take for granted every single day?
Well, the answer is the joints. These amazing structures are the absolute key. They transform our skeleton from just a static frame into a dynamic machine that's capable of some pretty incredible stuff.
So at its core, the definition is pretty simple, right? A joint is just the spot where two bones meet up. But here's where the magic happens. It's all about how they're connected, because the type of tissue that joins them together that determines literally everything about how that joint works.
Now, even though the idea of a connection seems straightforward, your body actually uses three totally distinct, kind of brilliant designs, and each one is perfectly tailored for a specific job. So let's break them down.
3. That's the magic number we're going to be talking about today.
Okay, here they are: fibrous, cartilaginous, and synovial. We're going to explore each one, and we'll start with the ones you might find kind of surprising, the joints that are specifically designed not to move much at all. Yeah, I know it sounds a little counterintuitive, right? A joint that doesn't move? But some of the most important joints you have are built for pure stability and strength, not for a huge range of motion.
So, our first type is the fibrous joint, and this one puts one thing above everything else: strength. With these, the bones are held together by this really tough fibrous tissue. The goal here isn't movement, it's to create an incredibly strong, locked-in connection.
And this is the perfect example. The different plates that make up your skull, they're actually separate bones, but they're fused together by these fibrous joints we call sutures. And you definitely do not want those moving around. This is a perfect case of a joint built for pure protection.
Okay, so what if you need that strength, but with just a little bit of give? A little flexibility. Well, that's exactly where our second type comes in, the cartilaginous joint. So for these, the connecting material is this tough but flexible pad of fibrocartilage. And the classic example is your spine. Each one of your vertebrae is connected by one of these joints, and that's what allows for that slight bend and twist, all while giving massive support to your entire body.
So let's do a quick recap of these first two. A fibrous joint uses tough fibrous tissue for an immovable lock, like in your skull. A cartilaginous joint uses a fibrocartilage wedge for just a little bit of movement, like in your spine. So it's strength versus a little bit of flexibility.
All right, now we get to the main event. When you think of a joint, you're almost certainly picturing a synovial joint. These guys are the absolute masters of movement.
So here's the blueprint for maximum mobility. Synovial joints are by far the most common type you have. Your shoulder, your knee, your fingers, you name it. They allow for the greatest freedom of movement, and they pull this off with a really clever structure: a capsule that's filled with a special fluid.
And this stuff, this synovial fluid, is absolutely essential. You can think of it like your body's own internal motor oil. It lubricates the joints so the bones just glide smoothly past each other. It absorbs shock when you do things like run or jump, and it even delivers nutrients to keep the whole joint healthy. Pretty amazing stuff.
But, all of that amazing movement creates a brand new problem: instability. It's this constant engineering trade-off happening inside your body, this tug-of-war between being mobile and being stable. So how does your body let a joint like your shoulder have that incredible range of motion without constantly popping out of place?
The solution, once again, comes down to a trio of factors all working together in perfect harmony.
See, stability is a total team effort. First, you've got the architecture, the actual shape of the bones and how they fit together. Second, you have ligaments, which are like these super powerful straps holding everything in place. And finally, the muscles around the joint provide active support, constantly pulling and keeping everything tight.
But what about a joint where the bones don't really fit together all that well? A great example is your shoulder, which is famously a bit unstable just so you can have that huge range of motion. So how does the body solve that puzzle? Well, it adds an upgrade. In joints like the shoulder and the hip, there's this little cartilaginous rim called a labrum, and what it does is it basically makes the socket deeper.
It acts kind of like a rubber gasket, creating a better seal and a more stable fit for the bone, giving you more security without really sacrificing that much movement. It's a brilliant little hack.
And that really is the big takeaway here. Joints aren't just one thing. They're a whole toolkit of different solutions. From the immovable strength of your skull to the slight give of your spine and the incredible mobility of your shoulder, they are your body's brilliant answer to the puzzle of movement.
So, understanding this incredible system is step one. But the final question, that's for you. Now that you know how it all works, how are you going to protect your body's most critical connections?